Now, once you know how to solve an equation, you usually have a pretty good idea then how to solve a related inequality. And that's going to become really important in calculus, because we will need to be able to solve various inequalities in our analysis of functions. So let's get an idea of how to do that now. So here I have the inequality negative 2 sine x plus 2 sine x cosine x is greater than 0, and I want to solve this over the interval 0 to 2 pi. Well, first we're going to solve the equation to find the roots of the equation, because if we can find where it's equal to 0, then we can tell where it's greater than 0 or less than 0. So first thing I'm going to do is I'm going to solve the negative 2 sine x plus 2 sine x cosine x equals 0. And we saw how to solve this in the previous subtopic. I can factor out, let's factor out a 2 sine x. So 2 sine x times negative 1 plus cosine x is 0. So then 2 sine x is 0, or negative 1 plus cosine x is 0. Alright, so if 2 sine x is 0, that means that sine x would equal 0, and so then x is 0, pi, 2 pi. And if negative 1 plus cosine x is 0, that means that cosine x is 1, and let's see, the cosine of x is 1 at, again, 0 and 2 pi. So now we have the roots of the equation. So now what we're going to do is we're going to use a number line and test subintervals. So here's my number line, and I have important numbers on it, and we're only looking over 0 to 2 pi, and all of the numbers are in that. So let's see, we have from 0 to 2 pi, and within that we have one important number at pi. Alright, so we have 0, pi, and 2 pi. Those were important numbers. Those were roots of the equation. So now what I'm going to do is I'm going to test in each interval. I'm going to pick a number between 0 and pi. I'm going to pick a number between pi and 2 pi. And I'm going to test them into the 2 sine x negative 1 plus cosine x. So let's test a number between 0 and pi. How about pi over 2? If x is pi over 2, then I would have 2 sine pi over 2 times negative 1 plus cosine pi over 2. Now all that matters here is it positive or negative? Alright, so 2 is positive. The sine of pi over 2 is 1, which is positive. And then I have negative 1 plus the cosine of pi over 2. The cosine of pi over 2 is 0, so negative 1 plus 0 is negative. So I have a positive times a negative. This is negative. And what that means is, if I found the boundaries correctly, and I've done my test correctly, everything in that interval, any choice of input in that interval would give me a negative output. Let's test a number between pi and 2 pi. I'll test 3 pi over 2. So testing x equals 3 pi over 2, I'd have 2 sine 3 pi over 2 times negative 1 plus the cosine of 3 pi over 2. The 2 is positive. The sine of 3 pi over 2 is negative 1, so negative. The cosine of 3 pi over 2 is 0, so negative 1 plus 0 is negative. A positive times a negative is positive. Now, I go back to what I originally wanted to solve. I wanted to know where it was greater, where that negative 2 sine x plus 2 sine x cosine x was greater than 0. So therefore, greater than 0, positive. There's the solution, that interval. So, I'll write the solution in interval notation. So, negative 2 sine x plus 2 sine x cosine x is greater than 0 on the interval from pi to 2 pi. Because that interval, for its inputs, gave me a positive output. So there's the solution. Alright, so let's take a look at this exercise. Negative 2 cosine x plus 2 cosine square x minus 2 sine square x is less than 0. One thing to note is that I typed this one down incorrectly at first, and so it's incorrect in the note sheet, so be sure to adjust it before you start working on it. If you want to, now would be a good time to pause. Try this one on your own. Alright, so what I see from this one is I've got, well, first, I need to solve negative 2 cosine x plus 2 cosine square x minus 2 sine square x is equal to 0. I need to solve this first. So what I would do with this is notice, well, I've got a cosine x, I've got a cosine square x, and I've got a sine square x. Let's replace the sine square x with an identity. So negative 2 cosine x plus 2 cosine square x, and then minus 2 times 1 minus cosine square x, using the Pythagorean identity, is 0. So then that's negative 2 cosine x plus 2 cosine square x minus 2 plus 2 cosine square x is 0. So then that's 4 cosine square x minus 2 cosine x minus 2 is 0. Alright, now this does factor easily. Let's see, we'd have a 4 cosine x and a cosine x, and let's see, we'd have a 1 here and a 2 here. 4 times 1 is 4, 2 times 1 is 2, and so I would need, since I need a negative 2, let's put a minus here and a plus here. That would give me a minus 4 cosine x and a plus 2 cosine x, so that fixes the middle. And so then this equals 0. And so then cosine x, so then 4 cosine x plus 2 is 0. Cosine x is negative 1/2. Cosine x minus 1 is 0. Cosine x equals 1. So over 0 to 2 pi, the cosine is negative 1/2. That would be at 2 pi over 3 and at 4 pi over 3. And the cosine is 1 at 0 and at 2 pi. Now again, if you weren't sure about the factoring, you could have used the quadratic formula to get to this point. That cosine x is negative 1/2 and cosine x is equal to 1. Alright, so now let's do some testing. Alright, so let's set up our number line. There's my number line from 0 to 2 pi. 0 is important, 2 pi is important, 2 pi over 3 is important, and 4 pi over 3 is important. So now let's test some values. I'll test pi over 2. Alright, now what to test into? Well, it doesn't really matter what you test into. Any of the forms are valid. From the beginning, well, any of the forms where you haven't divided by a negative, basically. So what I'll do is I'll test into the original expression in this case. So I'm going to test into the negative 2 cosine x plus 2 cosine square x minus 2 sine square x. So pi over 2, I'd have negative 2 cosine of pi over 2 plus 2 cosine square of pi over 2 minus 2 sine square of pi over 2. Pi over 2 is easy to work with. The cosine of pi over 2 is 0, so that would be a 0 plus another 0. Then minus 2, the sine of pi over 2 is 1, so sine square is 1. So I'd have 0 plus 0 minus 2 is negative. Alright, let me test between 2 pi over 3 and 4 pi over 3. Let me test at pi. So I'd have negative 2 cosine pi plus 2 cosine square of pi minus 2 sine square of pi. Pi is a relatively easy number to work with. The cosine of pi is negative 1, so I'd have negative 2 times negative 1 is 2, plus 2 times the cosine square of pi. Well, the cosine of pi is negative 1, squared is 1. Minus 2, the sine of pi is 0, so 2 times 0. So I've got 2 plus 2 is 4, minus 2 is still 4, positive. And then finally, let me test between 4 pi over 3 and 2. Let's test at 3 pi over 2. Not 2, but 2 pi, right? That should be a 2 pi on the end here. So then, testing the third subinterval, I'd have negative 2 cosine of 3 pi over 2 plus 2 cosine square of 3 pi over 2 minus 2 sine square of 3 pi over 2. Alright, the cosine of 3 pi over 2 is 0. So cosine square is, again, 0. Then minus 2 times the sine square, well, 3 pi over 2, the sine is negative 1, squared is 1. Negative 2 times 1 is negative. So this would, again, be negative. So, writing the solution. Sorry, I'm a little bit out of place on this one. My solution then, let's see, I want it to be less than 0, and so we go to the negatives on our subintervals. So there's the negatives. So then my solution is 0 to 2 pi over 3, union 4 pi over 3 to 2 pi. Those are the intervals where the output is less than 0.